Okay, let's have a look at question 5 from the January 2009 D1 paper. This is a route inspection question, and let's have a look. You've got a railway network and each track has to be inspected. Now that's how you know it's a route inspection question, because they tell you that each track, that's each arc, has to be inspected, so we know we have to pass across each arc in order to finish the problem. And we're told to use an appropriate algorithm to find the length of the shortest inspection route. So let's just have a look. And this is what you're given in your answer booklet. Same thing again. And if you remember, there are three types of graph. You have your Eulerian, and this means you've got no odd vertices. If you've got an Eulerian graph, it's very easy to inspect that graph, because you can traverse every arc once and only once and get back to where you started from, and that's very easy to do. If you've got a semi-Eulerian graph, this means you have two odd nodes, and this you can't traverse it and get back to the same place as you started from, but you can start at one of the odd nodes and finish at the other and still traverse each arc only once. So that's quite useful too. That'll come into the question later. And then of course you've got your non-Eulerian, and that happens when you've got more than two odd nodes, and the odd nodes always come in pairs, so you've got four or more odd nodes, and that's almost certainly what we're going to have here. Let's have a look. Let's count up the order of each node. So we've got two arcs coming off this one, so that's an order of 2. 1, 2, 3, 4, 5. Order of 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. And 2. So a real classic question here, because you've got 4 odd nodes. The first thing you want to do is list them. So odd nodes. This will help you make your working clear, and that's what you've been asked to do. So C, D, E, and G. And now the point of the route inspection algorithm is that we're going to create an Eulerian graph from one which is non-Eulerian. And the way we're going to do that is by joining up these odd nodes. And when we join them, what we find is that they become even. So if we add let's say we were to add an arc in between here, we'd find that we'd have an order of 4 here and an order of 6 here. So we've eliminated those odd nodes. We could also join those two up. They both have an order of 6. We'd have made ourselves an Eulerian graph, which is now traversable. Now the problem is, we want to make the Eulerian graph with the least amount of repetition possible. That will give us a minimum inspection route. So we're going to think about what pairings we can make in order to join up our odd nodes to create an Eulerian graph. So let's think about it. Let's take C as a starter. Possible pairings are C could go with D, and that would mean E would have to go with G. And the weight of this would be C to D would be 17 and E to G would be 19. So add that together, you get 36. Okay, but C wouldn't have to go with D. C could possibly go with E. So let's try that. C, E. If C goes with E, then D now has to go with G. So we got D to G. Now the shortest way to do this is 12 and 25. And that comes to 37. But C doesn't have to go with E, C could go with G. So C to G, and that would mean E would go with D. So we'd have 28 plus 13, and that comes to 41. So then we think, okay, which is the shortest way to do it? Well, 36 is the smallest number, so this little pairing is the most efficient one. So we'd only have to repeat 36 kilometers. So we would do C to D. This is what we're going to add in. C to D and E to G here. And now we've created an Eulerian graph which we can traverse, and we've only added in an extra 36. So the total weight is, well, we're given 543, that was the initial weight of all of these numbers added up, and then we add on that 36, and we get 543 plus 36 is 579. So let's have a look how we're doing so far. We've found the length of the shortest inspection route. It's 579. We made our method and working clear. They haven't asked us to actually list that route, so we don't have to go around writing out a path, but sometimes you do, so watch out for that. You might have to do, you know, F, C, G, E, and so on, write out the path itself, but here we don't have to. Okay, let's have a look at the second part. It's now permitted to start and finish the inspection at two distinct vertices. State which two vertices should be chosen to minimize the length of the new route. Okay, so basically what we have here is we're now allowed to be dropped off at one place and picked up somewhere else. Now if you think about it, if we had a semi-Eulerian graph, that makes the problem really easy, because we could get dropped off at one of the odd nodes and picked up at, let's say, the other one. Okay, so what we need to do now with this graph is reduce it down to a semi-Eulerian graph. So that means we have to do less repeats, so we can do a shorter route, shorter inspection route. The question is, which bits do we want to repeat? Well, we want to repeat, this time we only have to repeat one, because we can, let's say we repeat C and D, let's say. That means we can get dropped off at E, picked up at G, and we only have to, because this has created a semi-Eulerian graph, so we can traverse the whole graph not repeating anything, starting at E and getting picked up at G. Or, you know, we could add an arc in between, let's say, E and G, and then we could get dropped off at C and picked up at D. So there are various ways to do it, and in fact we've listed them already here. We've shown the possible ways to pair up the odd nodes. And look, if you look down, you can see that the shortest pair, or the shortest pairing of two nodes is C to E. So if we say that's the one we're going to repeat, that will only add 12 on. That means we can get dropped off at D, picked up at G, and we only have to repeat that 12, which is clearly the shortest out of all the options we have. So why don't we say for part B, repeat CE, start at D, finish at G. There's no reason, of course, why you couldn't start at G and finish at D, but let's go with the alphabetical order here. So that's how you would solve that question, question 5, the route inspection question on your D1 paper.